Welcome. So this is part 3 of the video for predictor paper 0620 chemistry MCQ paper 2. So we have done till now part 1, in which question number 1 to question number 16 was covered. Part 2, question number 17 to question number 32 was covered. Now coming to question number 33, which is in part 3 from a specimen paper for 2023, question number 10. So question number 33. The diagram shows the circuit. The diagram shows the circuit of used to electrolysis aqueous copper sulfate, which arrow indicates the movement of copper ions. We know that copper ions are going to be nothing but what? Positive ions. The positive ions will be always goes towards the negative electrode. Which is the negative electrode over here? The negative electrode is which is connected to the negative power supply. Cathode is connected to negative power supply, so therefore cathode is going to be the negative electrode. So copper ions will be going towards the cathode. So 2. So option 1 and A and B are wrong. A is wrong and B is wrong. Now we have to choose between C and D. Now we know that electrons move towards the positive power supply. So which is moving towards the positive power supply? 3. So whereas moving towards the negative power supply is wrong, so electrons move towards the positive power supply. So therefore option C is going to be the correct, and option D is also wrong option. Coming to the next question, question number 34 from November 2021. Paper 22, question number 26. Carbon dioxide is produced by the extraction of aluminium from bauxite. This is a diagram for extraction of aluminium from bauxite. You can see that molten aluminium is formed at the bottom, and we are using carbon anodes over there. And what is this? The bauxite is being fed from the up, and this is going to be nothing but what? Electrolysis. What is he asking? Now, which statement describes how the carbon dioxide is made? So carbon dioxide, how it is made? Because what is the thing is, we know that molten aluminium is made up at cathodes. At anodes, we will be getting it out oxygen. This oxygen, what will we do? Because the temperature is very high, which is 900 degrees Celsius in the electrolysis, this oxygen will burn the carbon in this cathode. So therefore, carbon dioxide is formed. So carbon dioxide, how it is formed? The carbon oxygen is made in the process of that reacts to carbon with the carbon electrode. So that is nothing but option C. So oxygen which is formed at the anode because of the high temperature of 900 degrees Celsius will react with the carbon at the cathode and forms carbon dioxide. So option C is going to be the answer. Why not option A, B, C, A, B, D are correct? So whereas we go to option A, carbon monoxide reduces aluminium oxide. So what he says that aluminium oxide, Al2O3 plus carbon monoxide gives rise to, he says that it is carbon dioxide, which is not possible because carbon cannot replace aluminium. Aluminium is highly reactive than carbon, so therefore this reaction is not possible at all. Whereas if at all you want to replace the what is any metal, it can be replaced what is if at all it is a ZNO, zinc oxide, or copper oxide, or PbO, or Fe2O3. Then what can happen is carbon can replace those two and what is this and take away the what is this oxygen from the metal oxides. But from aluminum oxide it cannot be possible because aluminum is more reactive than carbon in the reactivity series. So option A is wrong. Option B, carbon is burned in a blast furnace. This is not blast furnace, it's electrolysis. Blast furnace is useful for ion extraction. So but this is not an ion extraction. Therefore option B is also wrong. The ore of aluminium undergoes thermal decomposition. No, what is this? No oxides of metal oxides will undergo thermal decomposition. So Al2O3 cannot undergo thermal decomposition. So that's going to be the answer, option C. Carbon formed at the anode reacts with the cathodes to form carbon dioxide. Coming to the next question, question number 35 from June 2019, paper 22, question number 10. Aluminium is extracted by the electrolysis as shown. Just now we were learning about the electrolysis. Now which row shows the ionic half reactions at the cathode and the anode? Cathode is a negative electrode. So negative electrode means positive ions should be there. So it is obviously all A, B, C, D are positive ions. So aluminium, that's correct. But what is happening to the aluminium ion? Aluminium is Al plus 3. So it will be gaining 3 electrons rather than losing 3 electrons. So option A and option B are wrong because they are losing 3 electrons. So aluminium does not loses 3 electrons rather than what it says they gain 3 electrons. So it has to be either C or D. Coming to the next, oxygen. Oxygen at anode, what will happen? It will lose 2 electrons. So therefore option C is correct and option D is going to be wrong. Oxygen will not gain electrons, whereas oxygen will lose electrons. Aluminium will be gaining electrons to form aluminium. So option C is going to be the answer. Coming to the next question, question number 36 from June 2021, paper 21, question number 10. In separate experiments, electricity was passed through aqueous sodium chloride. Aqueous sodium chloride means I have Na plus, Cl minus, H plus, and OH minus. And molten lead bromide. Molten lead bromide means I have lead ions and bromide ions. What would happen in both the experiments? So a halogen would be formed at anode. So what is anode? Anode is going to be a positive electrode. So at the positive electrode, a negative bromine can go and a chlorine can also go. So therefore, it is correct. Option A is correct. Why not option B, C, D are correct? Let us see. A metal will be formed at the cathode. So metal will be formed at the cathode? Yes. It may be possible what it says, metal is formed at the cathode in the case of what is the second experiment. In the case of second experiment, a lead is formed, that is correct. Whereas in the case of the first experiment, hydrogen is being reduced rather than Na plus. So therefore, Na plus will not be reduced and will not be getting it out sodium in the at the cathode. So option B is wrong. Option C, hydrogen would be formed at anode. First of all, in what is this experiment number 2, there is no hydrogen at all. Only hydrogen being a positive ion, it will be formed at nothing but what? Cathode, which is a negative ion. But he says that hydrogen is formed at anode, so option C is wrong. Option C is wrong in two fronts. First of all, there is no hydrogen in the second experiment, and what is this? Hydrogen should be formed at cathode. Option D, it may be partially correct. Yes, it is formed at cathode, just now we have learned, but there is no hydrogen in the second experiment. So that's why it is also wrong. So option B, C, D are wrong. So only option A is correct. That's going to be. Next question, question number 37 from June 2020, paper 22, question number 10. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? Dilute aqueous sodium chloride. So dilute aqueous sodium chloride means I have Na plus, Cl minus, H plus, and OH minus. Now we know that hydrogen will be going to the cathode, that is 100% correct. And because it is dilute, the OH minus instead of chlorine, OH minus will go to the anode and oxygen is formed. If at all it would have been concentrated, Cl minus would have been gone, but it is a diluted, so there will be more number of OH minus. They go to the anode and an oxygen is formed. That's 100% correct. Concentrated hydrochloric acid, so H plus and Cl minus. Now chlorine, because just now we told that if it is concentrated, Cl minus goes to the anode and chlorine gas is formed. That is 100% correct. And as usual, hydrogen goes to the cathode and forms. So for option number 1 and option number 2 is correct. Molten aluminium oxide. Aluminium oxide is Al2O3, which is nothing but what? Al plus 3 and what is this? O minus 2. Metal will be always going to the cathode, but here says that metal is at the anode, so which is option 3 is wrong. Moreover, oxygen goes to the anode, but it has been given that oxygen is going to the cathode, so therefore option 3 is totally, they have switched it out. So aluminium should be at the cathode and oxygen should be at anode, so that is wrong. Now concentrated sodium bromide. Concentrated sodium bromide is Na plus and Br minus. Now what will happen is bromine will go to the anode, that is 100% correct. Bromine goes to the anode, that is okay. Now because it is concentrated, what is happening is we will be having it out H plus 2. H plus also. So H plus will be forming at cathode rather than Na plus, because Na plus is highly reactive. It will continue to remain it as Na plus rather than taking an electron and becoming as Na. So hydrogen will be less reactive and it will be taking it out the extra electron. So therefore option number 4 is also wrong. That's going to be the answer. Option 1 and 2 are correct. So over here the options are missing. So let me write it out of the options. Option A is 1 and 2. Option B is 1 and 4. Option C is 2 and 3. And option D is 3 and 4. So we can see that option A is correct, which is option 1 and 2. Coming to the next question, question number 38. It says from November 2029, paper 2, question number 11. Which rows correctly show cathode and anode products from the electrolysis of the named electrolyte? Copper sulfate solution using copper electrodes. Copper is going to be an what is this? Active electrode. If at all it is in an active electrode, what will happen is it will be acting as an anode, and at anode the copper goes to the anode, and what is this? It will be losing 2 electrons and it will be forming it out copper plus 2. So if at all it is an active electrode, the copper will be going to the anode and it loses 2 electrons. And what is this? A copper plus 2 is formed. So therefore, what is this? We can say that copper plus 2 is formed at anode, but here he is saying that it is oxygen, therefore it is going to be wrong. Now molten sodium bromide. Molten sodium bromide means nothing but what? I have Pb plus and Br minus. So, and what is the thing is, bromine goes to the anode, that is 100% correct, and what is this? Lead goes to the cathode, that is also 100% correct. So therefore option 2 is correct. Now, dilute sodium bromide solution. Dilute sodium bromide is nothing but what? Dilute means H plus, OH minus, and Na plus, and Br minus. Because it is dilute, hydrogen will go to the cathode, that is 100% correct, and OH minus will go to the anode, and oxygen is formed. So that is option 3 is also correct. Now coming to option number 4, copper sulfate solution using carbon electrodes. Carbon is nothing but what? Inert electrode. It is an inert electrode. So therefore, what will happen is, in that copper sulfate solution, I will be having Cu plus 2, SO4 minus 2, H plus, and OH minus. Now, what is the thing is, because it is an inert, so copper plus 2 will be going to the cathode. If at all it is active, copper will be going to the anode. If at all it is what it says inert, copper will be going to the what is this? The copper plus 2 will be going to the cathode. So copper plus 2 should go to the cathode, and I should be getting it out copper rather than nothing but what? Hydrogen. So therefore option 4 is wrong. So therefore option 4 is wrong. So we have only option 2 and 3. So which is option 2 and 3? C. That's going to be the answer. Question number 39, it is from specimen paper 2023. Question number 12, which diagram is correctly labeled reaction pathway diagram for an endothermic reaction? For an endothermic reaction, remember that a lot of energy is gained and a little amount of energy is released. So you can see that in this one, a lot of energy is gained. This is gained, but a very little amount of energy is released. So this is going to be an endothermic reaction. The same is the case, a lot of energy is gained and very less amount of energy is released. So this can also be an endothermic reaction. But whereas these two are not, because the thing is, over here, a less energy is gained and more amount of energy is released. Over here also, less energy is gained and more amount of energy is released. So gain is less than release, a gain is less than release, gain is greater than release, and drain is greater than release. So therefore, what you says option A and option B are correct. Now we know that option C is wrong and option D is wrong. Now among option A and option B, which one is going to be the correct option? We can clearly see that this energy is called as activation energy, and this is the overall change in the energy, final minus initial, because this is the initial and this is the final. Final minus initial is going to be called as overall energy change. It is not called as activation energy. So option B is also wrong. So therefore the answer is option A. Coming to the next question, question number 40 is from March 2019, paper 13, question number 13. Hydrogen reacts with chlorine according to the following equation. H2 plus Cl2 gives rise to 2HCl plus, obviously it is nothing but what? Heat, because it is an exothermic reaction. Which statement is correct? We know that this is a graph for exothermic reaction, so we can see that a very less amount of energy is gained and a more amount of energy is released in an exothermic reaction. So according to the first option, energy absorbed is greater than the energy released. No, should be the other way. Energy released should be greater than the energy absorbed. So first option is going to be wrong. Second option, energy absorbed for bond breaking is less than the energy released. Yes, energy absorbed is less than the energy released. So therefore, second option is going to be correct. Now coming to the C and D, why they are wrong? Energy released in bond breaking. So it is not released in bond breaking, it is absorbed in bond breaking. So energy is absorbed in the bond breaking. So therefore, option C is also wrong and option D is also wrong. So therefore, the answer is only going to be option B. Coming to the next question, question number 41 from November 2020, paper 23, question number 16. The reaction between hydrogen and oxygen releases 486 kilojoules per mole. Releases means delta H equals to minus 486, not plus 486, minus 486. The bond energy of HH is given and OHO is also given. Find the bond energy of what is this? O double bond O. So we have to make a table over here. So let us make a table. So what is that table is about? Bond making and bond breaking. So bond breaking and bond making. We make two columns. So what are the, first of all, the equation? Let us write the equation. What does it becomes? H single bond H, two times it is there, plus O double bond O gives rise to H2O, OH and OH, and another one because there are two molecules of water. So we can see that there are, what are we doing it out? We are breaking two molecules of hydrogen, two hydrogen bonds, so 2 times of 436, which is nothing but what? 872. And for oxygen, this is for H single bond H, and O double bond O, we don't know, we have to calculate it out. So totally it will become 872 plus X. Now coming for bond making, O single bond H is nothing but how much? 464 given, but how many such are there? We can see that 1, 2, 3, 4 are there. So times 4, which is going to be nothing but what? 1856. Now delta H equals to 807. Delta H equals to 872 plus X minus 1856. So bond breaking minus bond making. So delta H is nothing but what? Minus 486 equals to 872 plus X minus 1856. From here, X we am going to get it out directly. I'm writing. So answer is 498. So which option is that one? 498, option C. That's going to be the answer. Coming to the next question, question number 42. It is from November 2020, paper 22, question number 15. Hydrogen reacts with oxygen in a fuel cell. The reaction is exothermic. 286 kilojoules of energy is released for every 1 mole of water. What volume of hydrogen gas measured at room temperature and pressure would react with oxygen to release 7,000 joules of energy? So he's asking about volume. So if at all I want to know about volume, I will be finding out the moles. Why? Because volume equals to 24 times N. So if at all I know the moles, then automatically I will be able to calculate the volume. So over here he has given that 1 mole of hydrogen is giving us 286 kilojoules. So how many moles we want? 7,000 joules. 7,000 joules is given by how many moles? Let it be X. So convert 7,000 joules into kilojoules, 7 kilojoules. So it becomes X equals to 7 divided by 286, which will become 0.0245 moles, these many moles. So now as such, we know that volume equals to 24 times 0.0245, which will be becoming nothing but what? 0.587. What are the units? dm cube. So it is 0.587 dm cube. So but the answer is nothing but what? 587 cm cube. So convert into cm cube, it will become multiply by 1000. So 587 cm cube. So which is the option? Option A is going to be the answer. Coming to the next question, question number 43 from March 2020, paper 22, question number 13. Which statements about hydrogen fuel cells are correct? So the reaction between hydrogen and oxygen is endothermic? No. So it is nothing but what? It is an exothermic reaction, and it is used in the production of electricity. So that is the main meaning of using hydrogen as a fuel cell. We want to release energy rather than absorb energy. So therefore, it is an exothermic reaction to generate electricity. So therefore, first option is wrong. The waste product of the hydrogen fuel cell is water. Yes, the water is formed because what is the reaction? We have the reaction H2 plus O2 gives rise to H2O. So we can say that it is going to be the water is going to be the waste product, but it is not a pollutant. It's a good waste product. The chemical reaction in the cell produces hydrogen? No. So we have just seen that it uses hydrogen. Hydrogen is a reactant. It's not a product. So therefore, third option is also wrong. So just now we have learned that fourth option, it is used in the production of electricity, is correct. So therefore, option 2 and 4 is correct. So which is that option? Option C. Now coming to the next question from June 2020, paper 23, question number 14, which is our question number 44. So which of the following is a physical change? So we can see that there is iron nail. Iron nail is nothing but iron plus Fe plus oxygen. It will react and form it out Fe2O3 and H2O, means nothing but what? This is a rusting process, which is a chemical change. It's not going to be a physical change. He's asking about which is a physical change. Now coming to this sodium chloride, we can see that yes, sodium chloride NaCl it just get dissolved and forms Na plus ions and Cl minus ions. So there is nothing more reaction is forming it out. No reaction is taking place. So therefore, B is going to be a physical change. Why not C and D? Let us see that one. C, what is happening? The magnesium strip is reacting with nothing but what? Dilute hydrochloric acid. So we will be forming it out, or MgCl2, and the bubbles are nothing but what? Hydrogen gas. So these bubbles are hydrogen gas. So it is a chemical reaction. So A is a chemical reaction, C is a chemical reaction. What about D? D is nothing but what? It's a calcium carbonate plus dilute hydrochloric acid, which will be giving me nothing but what? Calcium chloride plus carbon dioxide. So that bubbles are nothing but what? Carbon dioxide. So therefore, this is also going to be a chemical reaction. So only option is B, which is a chemical physical reaction. Option B is question number 45 from June 2020, paper 21, question number 14. Which diagram represents a chemical change? We can see that this is the particles, so the molecules are very wide apart, so it can be a liquid, and now they are coming very closer together. It is becoming a solid. So liquid is becoming a solid, so it's going to be nothing but what? A physical change. Whereas over here it is again in the form of a liquid, and again they are getting very far, so liquid is becoming gas. So this is also nothing but what? Boiling, a physical change. In boiling, liquid becomes gas. Whereas in the third one, part C, you can see that this is also looks like a boiling. The part B and part C both looks like boiling. Why do they both looks like boiling? Because the thing is, the particles are getting wider apart, and now what is this new compound is formed. See, we can see that this diatomic molecule is continued to remain as diatomic molecule. Monoatomic molecule continue to remain as monoatomic molecule, but only the distance is increasing. So it is nothing but what? This is in the form of a liquid, and this is in the form of a gas. So boiling is taking place. And finally, in part D, it can be a chemical change, because you can see that this diatomic molecule is getting broken and it is combining with this gray color particle. So a new bond is formed. So therefore, we can say that this is going to be a chemical change. So which option is that? Option D is going to be a chemical change. That's going to be the answer. Question number 46 from June 2019, paper 2, question number 13. Which change in reaction condition increases both collision rate and the proportion of molecules with sufficient energy? Both have to be increased. Not only the collision rate, but also the sufficient energy to react, both. So this can be done only with the increase in the temperature. Why not catalyst? Catalyst, what it will do? It will decrease only the activation energy. It will decrease only activation energy. Therefore, what it says, catalyst will not do both. Increasing the concentration, I know that increasing the concentration will increase the collision rate. Collision rate will increase, but nothing to do with the sufficient energy. So option B is wrong. Option C, increasing the surface area, it also increases the collision rate, but nothing to do with the sufficient energy. So therefore, surface area is also not the correct option. So only the correct option is nothing but what? Increasing the temperature of the reaction, which increases both the collision rate and also the sufficient energy to react. Coming to question number 47, which is from March 2020 and paper 22, question number 15. A student adds excess of magnesium ribbon, excess, to 10 cm cube of 0.5 mole per dm cube of sulfuric acid. So whichever is in excess, the other one will become the limiting reagent, or limiting reactant, to be more precise, limited reactant. So the other one will become the limiting reactant. So sulfuric acid is going to be the limiting reactant. What is the meaning of limiting reactant? It will be deciding the products, how much of products are, how much volume of products are formed. More the limiting reactant, more the volume of the products. The less the limiting reactant, less the volume of the products. So over here we are deciding the products is nothing but what? Hydrogen gas is, and its volume is measured every 10 seconds. So from these four diagrams, we can see that A is having more amount of limiting reactants. D is having the less amount of limiting reactants. And what is original experiment? What is the original experiment? It is 10 cm cube and 0.5. So volume equals to 10 cm cube, and the what is this concentration equals to 0.5 mole per dm cube. This is the, so more limiting reactants gives you the experiment A, and less limiting reactants will be giving you the experiment D result. And B and C are both are same because they are ending up in the same. So if at all you want to know the values, we can check the values also. So what is that is, this is 5 lines are there, and between 0 to 50 means each line is 10. So this is going to be nothing but what? 60, and this is going to be 120, and for A it is going to be 240. So the originally it was 120, and if at all it can be either 240 or 60. So how should we know? Now the experiment is repeated using the same amount, same mass of magnesium ribbon, but 5 cm cube of 0.5 mole per dm cube sulfuric acid and 5 cm cube of water. So what is happening over here? Initially, in the initial or in the original one, in the original experiment, what is happening? I am taking 10 cm cube of sulfuric acid. Whereas in the new experiment, what is this? I'm taking only 5 cm cube of sulfuric acid. 5 q 5 cm cube of sulfuric acid. So means obviously I'm decreasing the what is this volume by half, but simultaneously I'm adding 5 cm cube of water, but that water is of no use because just we are diluting it. So don't think that both are the same with 10 cm cube and 10 cm cube. It is not the same. We are supposed to take the volume of the acid, not the acid plus water. So initially the volume was 10 and finally it became nothing but what 5. So the volume has decreased by half. So when the volume has decreased by half, the volume of the products also will be decreasing by half. So we will be getting it out from 120 to 60, which is nothing but what option D. So answer is option D. Now coming to the question number 48, which is from specimen paper 2023, question number 14. The diagram shows an experiment to measure the rate of a chemical reaction, which change decreases the rate of the chemical reaction. So for example, I'll come from the option D. Using a powdered metal, it is wrong because why? If you increase powdered metal, the surface area will be increased. Surface area increases means the rate of reaction will increases. Using a concentrated acid, it is also wrong because more molecules are added. So obviously more collision rates and the rate of reaction will increase. And heating the flask is also wrong because more temperature, more energy, more collisions. So therefore, rate of reaction also increases. Only adding of the water to the flask will decrease the rate of reaction because the thing is, it will dilute the reactants and obviously there will be less collisions and obviously there will be less rate of reaction. So option A is going to be the answer. So that completes part 3. See you in part 4 for the next few questions. See that this is a 5 to 6 parts of videos wherein we are targeting top 100 questions which are most expected to come in the upcoming examination for 0620 MCQ paper 2 chemistry of CAIE. So see you in the next video. Bye.